Welcome back, 6th grade. Happy Friday, May 1st. Can you believe it is May already? I feel like this quarantine has been both really slow at times, but also it's gone by really fast at the same time. So this is just, it's crazy to me that it's already May. But we have arrived, and it's the weekend after this, so yay! We are going to be going over your lesson review questions 8.1.2 and the worksheet 8.1.2 Life Cycle of Stars that you should have completed for homework that was given out in the last video lesson. So go ahead, I'm going to pause this and get your answers to your lesson review questions that you emailed me, and go back and make sure you get the right answers. I'm going to read them fairly quickly, but again, just pause the video and make sure that you understand why the answer is what it is. All right, and so let's get started. Number 1 said, what two factors are being compared in the HR diagram? So the correct answer is that on an HR diagram, we are comparing a star's spectrum and its absolute magnitude. Okay, or you could say we're comparing its temperature and its luminosity or brightness. Okay, absolute magnitude and spectrum are just the more official terms for that. Number 2, in what portion of the HR diagram will a star appear for the majority of its life? We touched upon that in the last video lessons. The correct answer to that is the main sequence. That is that band that goes through the HR diagram, and that's where the majority of a star's life cycle is spent. Number 3, if a star has an absolute magnitude of 0 and a surface temperature that is cooler than the sun's, where would it be located on the HR diagram? Okay, so we have to think about its absolute magnitude and its temperature. So since it is cooler than the sun, okay, it's going to be above the main sequence, so above that band, and on the right side of the diagram. And if you were confused on that, make sure you go back to the video and go back and take a look at the HR diagram. And you can see, remember, dimmer stars are at the bottom, brighter stars at the top, and their temperatures affect where they're plotted on that. And so if we know that the star's temperature is cooler than the sun's, that gives us an indication as to whereabouts it might be on the HR diagram. Number 4, how is a star born? All right, a star is born because large clouds of gas and dust and particles called the nebula condense from their own gravity. Remember, we demonstrated that they condense under their own gravity, and as their density increases, the nebulae become much hotter, and they get hotter and hotter. And when enough heat is present in the center, nuclear fusion can occur, and it combines hydrogen atoms to form helium atoms, and the star is born. So as we go from hydrogen to helium atoms, the star becomes born. Number 5, how are white dwarfs created? Remember, that's that type of star towards the end of its life cycle. So average size stars, remember we had the two choices if we looked at that image from your workbook and from the slides, where you could become an average star or a massive star. So if you become the average star, you lose your outer layer of gas over time. Eventually, a small, hot, a very faint core is left behind, and that's the white dwarf. Okay? Not to be confused with if you become a massive star and you become a neutron, right? Neutron star or black hole. This is for average size stars. You can become a dwarf star, or a white dwarf, I'm sorry. And number 6, last question. Why are black holes not visible? Black holes have such a strong gravitational pull that not even light can escape, so they cannot be seen directly. Okay, remember, so light was the fastest traveling thing on Earth and in creation, and it is even so fast and the gravity is so strong in a black hole that light cannot even escape. All right? All right, and so this is just that image again. I wanted just to point this out one more time before we go over the worksheet, but this pretty much resembles the exact worksheet that you completed from your workbook. Again, just going with where a star starts in its life cycle, becoming an average star, a red giant, a planetary nebula, or a white dwarf, or becoming a massive star, a red supergiant, a supernova, and having the possibility of either becoming a neutron star or a black hole. So please, please, please make sure you're familiar with this, and your answers to your worksheet should look something like this. Okay? So again, you can see this is almost exactly the same as that other image there. The stellar nursery, small star, or we called it the average star, red giant, planetary nebula, white dwarf, massive star, red supergiant, supernova, or one of the two, neutron or star or a black hole. All right, and so this is a short video for today. I just wanted to get you guys those answers. Make sure you're checking your work. I will be sharing a link for you guys on your Planet Project videos here. So you will be getting a link at some point for a private YouTube video that will have just a compilation of all of your individually recorded Planet presentations. So yes, as of right now, the plan is to get that link out to you so that you can watch your classmates' presentations, and then you're going to be completing a discussion question section on ClassReach. And so on the next slide here, I've kind of shown you a little bit what that's going to look like, and more information will come in an email for this as well, but I just wanted to go over it here really quickly. You will be going right onto ClassReach, so log onto your ClassReach, and at the top you'll see this new function if you haven't used it in any of your other classes yet. I've used it a few times. You are going to click discussions. It's the beta version because it's kind of it's a test out version that they're doing. And I'm going to be posting a discussion question, and what you're going to do is you're going to just respond to the discussion question. And what you're going to respond with is you are going to answer these two questions for any 3 classmates. Okay? So you're going to go on and you're going to share 2 things that you learned from watching them give their presentation, and then you're going to praise them for something they did a great job on. All right? So be sure that you're telling us who you're responding to, and remember that you're doing it for 3 different classmates for a total of 6 responses. So this might look like, for me, if I was a classmate, I might watch all the videos, and then I might say I learned 2 new facts about the planets that Lily did, and then I'm going to say 1 positive thing about Lily's presentation video, something I liked. Did she speak nice and clearly and loud? Did she do a really good job on her poster board, or whatever she did? So you're going to share 2 things you learned and something that you think your classmate did a good job on. Then you're going to do that again, and you're going to say, I think Liana did a great job, and I learned these 2 things from Liana, and so on and so forth. And then you're going to do that one last time. I think Hunter did a great job with whatever. All right, so you guys hopefully get the gist. You're picking any 3 classmates to share 2 things you learned from their presentation and praise them for something great that they did, so that we can be an encouragement to each other and give each other some positive and constructive feedback for future presentations. All right, so more details for that to come. And with that, guys, it is Friday. Go enjoy your weekend, do something fun, take a break from schoolwork, try a new hobby, get some fresh air, whatever you got to do. But I hope you have a wonderful weekend, and I will see you soon.